Hello friends, so let me welcome you to another video on probability and its basic. Today we are going to learn probability, and also we are going to learn confidence interval. I have seen many students struggling in this topic because of lack of clarity. In today's video we will understand each and every steps involved in probability distribution, and different types of distribution that we have, and also we will understand many interesting facts about probability. So today's objective, if I want to summarize, it is going to be something like this. First, we will understand about basic probability. Second, the sample space and random variable. Third one, probability distribution. Fourth one, probability mass function, probability density function, cumulative distribution, and sample distribution and sampling distribution. Okay, and we will also learn how to calculate confidence interval, and we will solve some problems so that we are very clear about everything that we discuss in this topic. Okay, so let me give you some basic idea about probability, why this probability is a very big tool for us to analyze uncertain cases. Typically when we see things around, we will see that many things are very certain. There are certain cases and some are not very certain. Let's take one example. Let's say if we want to add 2 plus 2, it is going to be 4, right? So it is very certain. It is going to be 4 here, anywhere else it is going to be 4. This is very certain. There is no change in it. But all the cases are not certain. For example, there are some cases where we are not sure about the outcome. In that case, we use probability. For example, if you toss a coin, what is the probability of getting a head is not certain. Like 2 plus 2 is equal to 4. If you toss a coin, most probably you will get either head or tail. So what are we sure about? We are sure that there are 50% chances are there that you will get a head or you will get a tail. So in this case we use probability, and here in these two cases we will see that probability is going to be 1/2. 1/2 is nothing but 0.5, or 50% chances are there that it will be head or tail. Typically when you tossed, you may find something like this, that first toss you got head, second toss you also got head. This is by chance you are getting 2 heads. But if you repeat this experiment many times, typically you will have 50% chances of heads and 50% chances of getting a tail. Okay, so we are not certain about the outcome, and hence we use probability. Okay, if we do this exercise many times, most likely the answer is going to be 1/2 and 1/2, and if you add all the probabilities of outcomes, then the answer is going to be 1. Okay, so most of the cases it is like that. Okay, so sum of all the probabilities is always equal to 1. So take a dice and roll it. So there are possibility of 6 outcome because there are 6 numbers in this dice. So what is the probability of getting 2? Is also 1 by 6. What does it mean? There are 6 possibilities. Out of that you are looking for 1, so it is 1 by 6. So like that, if you add all the numbers probability, it is going to be 1 by 6 plus 1 by 6. Like that you add 6 times and it is going to be 1, and that is how we are getting this as. So how do we understand probability using a line, number line, where you have got probability extreme values like 0 and 1. So in this case, typically you will find if you have more outcomes, then probability of getting each is less. So then you will see that it is somewhere in this less likely range. If you have a event or experiment where the probability outcomes are less, probably you will find that the values are going to be closer to this. For example, in case of tossing a coin, it is going to be exactly at half, which is 1 by 2. So this is how we understand certain cases and uncertain cases. Let's make it more challenging. How do we now complicate the thing so that you understand it better? Let's take one example. We have a bag which has got 30 balls, out of which 10 are red balls and others are blue balls. So in that case, what is the probability of getting a red ball is a very interesting exercise. Let's say what we have is 10 red ball, 20 blue ball, total is 30. So what is the probability of getting a red ball? How many red balls are there? 10. So it is 10 divided by total number of balls, which is 10 by 30. Similarly, what is the probability of getting a blue ball? So how many balls are there? 20. It is 20 divided by 30. Right? So you can always get answers like this for this. Now, once we are clear about this probability thing, now you go to probability distribution. And here we talk about a random variable. Random variable is not something which is coming randomly, but it is of an experiment that you are doing, and all the possibilities you are taking into consideration, and then you are defining a variable which is a random variable of all these probabilities corresponding to this probability. Okay, so the value correspond to the outcomes of a random experiment or trial is called a random variable. We will see in a moment. Okay, so let's say we toss two coins together. So in this case, what are the possibilities of our outcomes? So outcomes can be of 8 different types. 8 different types can be explained, 4 different types, because here we are tossing it for 2 times. 8 we will discuss in the next slide, where we are tossing it for the 3 times. So the value that you are getting is how many different types of outcomes you can get is summarized here, which is 2 to the power number of times you are tossing. So 2 is because of 2 outcomes, head and tails. So it is 4. So here all the outcomes, if you collect and put it in a place, then in that case that particular space is known as sample space. Like in this case, the sample space has 4 outcomes. These are head, so the two times you are tossing, so you may get 2 heads, or you may get 1 head and 1 tail, or you may get first one as tail and second one as head, or both tails. These are the sample space, all the possible outcomes in this. And once you have possible outcomes, then you define then you find out the random variable that we will see this. Okay, what is the probability of getting 2 heads? This is how you define a random variable, and here in this case you are talking about probability of getting 2 heads. So the probability is how many what is the probability of getting 2 heads is how many 2 heads are there. You can see that only 1, so it is 1 out of 4, so it is 1/4. Similarly, you can get probability of 2 tails, probability of 1 head, probability of 1 tail, and 0 head and 0 tails. So this is how you get the probability from the sample space. Okay, so probability distribution can help us with all the possible outcome. We'll see in a moment. Now, in this context, we also define a random variable as discrete and continuous. Very simply, if I want to define, discrete is the one where you can count how many, like what we did in case of tossing a coin. We have 4 different outcomes. But in some cases, it may not be that certain, and hence we use continuous random variable. What is continuous means? That basically means within 2 numbers anything is possible, and there are unlimited possibilities, and hence we call this as continuous random variable. Okay, so we will see this in a moment. Okay, so in case of tossing a coin, we know that it is countable, and hence it is discrete. Okay, there are many examples, like if you have a deck of card, in that case what is the possibility of getting one heart? So you will find that as probability, which is you can easily count. Okay, so in case of continuous variable, continuous random variable, it is infinite possibilities, and hence you are calling this as continuous. Okay, so for example, you are measuring 100-meter race results, and in this case you can see that there are possibility of anybody getting any timing, and hence it is continuous. There are infinite possibilities are there, and hence we call this as continuous random variable. Okay, so what is the probability distribution? Probability distribution is of a random variable where you are continuously tossing, let's say, 2 coins. So what are the possibilities? This we have seen. So here we are defining a random variable as heads. So there are possibilities of getting 1 head, 2 heads. So let's see what is, and there is possibility of 0 head as well. So 0 head, you can see that it is 1/4, because if you get 2 times tails, then in that case they will not be. So the random variable is x, which is number of heads that you are getting in a sample space. Okay, so here we have got 4 possible outcomes. So in this case we are just talking about all possible heads. So in this case, if you want to plot it with their probability, that becomes probability distribution of a random variable. And what is here random variable? Random variable is number of heads that you are getting. So here the possibilities are explained in terms of numbers. Here, for example, the random variable can take 0, 1 and 2 values, and the probability, corresponding probability that you have. So this is how you get the distribution, right? Here we have shown distribution in terms of histogram, because we can quantify these three possible. Okay, let's try the same thing, same experiment, but this time we are adding one more toss. That basically means we are tossing the coin 3 times simultaneously. So in this case, what could be the sample space? So you can say that it is 2 to the power 3, which is equal to 8. So 8 possible outcomes that you are going to get, and 8 possible outcomes are mentioned here. 3 heads, 2 heads, 1 head and 2 tails, like that. We have got 8 possible outcomes. And let's see how we can understand probability distribution using these 3 tossing of coin. So here again we are defining our random variable as number of head. So what are the possibilities? You can get 0, that means no heads. You can get 1 head, and you can get 2, you can get 3. So this, like this, you have got 4 different values for this random variable. So probability of this can be explained very easily. Probability of getting this, because there are 8 outcomes. So how many times you are getting 0 heads is 1, so 1/8. How many times you are getting 1 head is 3/8, and 2 heads 3/8, like that. You can get all the possibilities, and using this you can have a distribution where you can see that random variable is explained in this x-axis, where there are 4 possibilities, and then probability is this side. So you get the probability, and this is what is known as probability distribution of a random variable, which is x in our case. Okay, so this particular thing is also known as probability mass function. Okay, probability mass function is always for the discrete random variable where you can count it, right? But when it comes to continuous one, then this is known as probability density function. Okay, so now let's talk about other types. So from probability mass function, you can always find another distribution which is known as cumulative probability distribution. So cumulative probability distribution basically is very simple exercise that you do. You just add all the probabilities simultaneously, one by one, and then the value that you are getting is plotted, and that plot is going to give you cumulative probability function. So here we have already done this exercise, which is probability mass function, and from this you are getting probability cumulative probability. It's very simple. For example, here we have got 0.12, so that is the first block, and then the second block is added to the first block, and here this becomes 0.5. So that basically means probability of getting at least 1 head is around 50. So it's always less than whatever is covered here. And like that, if one more interesting thing that you can see, that it starts from 0 and it goes up to 1. Okay, it goes up to 1. So this is what is cumulative probability distribution function. Okay, so this is another exercise that you can get by just adding all the probabilities of possible outcomes. Now let me try and explain in case of a kind of dice where we have got 6 possible outcomes. So here all the probabilities of 1, 2, 3, 4, 5, 6 is 1 by 6. So in this case you can see that probability mass function is the same number, and here probability is 1/6, which is 0.16, and in this case probability cumulative probability distribution function is going to be like this. So it's very simple, just add the next one to it to get the second. For example, the first one is this one, second one is this plus this, third one is this plus this plus this. So like that you can see that it goes from 0 to 1. Okay, so from probability density, from this we can also find the same probability distribution for a continuous random variable. In that case what we are going to get is a kind of curve which is continuous in nature, and it looks mostly like bell-shaped kind of curve if you have got large number of observations. And here in this case we have collected, let's say, mean weight of many people, and then we found that majority of people are in the range of 55 to 61, and with the mean 58. So more or less you will find that mean is 51. So very high weight people are going to be less, and very low weight also going to be less. So more or less majority of your people are within this range, which is very close to the mean, which is 58. Okay, so this is how you can get the probability of you can also mention the probability of this. So this is how you get. So now the interesting question is, how do we find out cumulative one? Cumulative one is again something like this. If you have got something like values where it starts from negative and it goes to this, so this is just adding each successive one, so you get a continuous line, something like this as cumulative distribution function. Now interesting thing is, mostly in real life when we deal with problem solving, we take this normal distributed curve and then we match with the problem at hand. So this is used as a kind of scale where you assume or you test whether your distribution is normal or not, and if it is normal, then it is very easy for you to deal with this kind of problems. We will see this in a moment. Sampling distribution. Sampling distribution is again a very interesting tool in the hands of statistician and decision makers. Is this because sometimes what happens is the population is so large, it is not possible for you to check each and every person's weight or temperature or whatever you are trying to find out, and in that case you normally take a sample. Okay, so if you take a sample and you try to explain about population parameters, then this statistics probability helps in a big way, because it saves a lot of time and energy for you to use sample to predict about the population. Okay, so how do some examples, some real life examples where you may be doing it but without knowing that you are actually using sampling distribution. Now have you seen that if you go and buy rice, typically there are a bag full of rice in the shops. So what you see, you just take handful of rice to just see how the quality of rice is in the bag. So typically you take one handful of rice and see if it is nice or not. But if you want to be extra sure, what you do is you take not only just one from the top, but also you take from the bottom or different parts of that particular sack of rice to predict about that population, with the belief that whatever outcome you're getting out of sample is going to explain this parameters of population. And this is what we normally do in real life, and we also do this in case of of statistics in predicting our population parameters. Okay, so sample distribution is the first case where I explain you took only one sample to predict about the bag of rice. So that is what is sample distribution. But when you talk about sampling distribution, where you take many samples of the same population or same bag of rice to predict about the quality of rice in the entire bag, which is your population. So if you have got sampling many samples, then the probability of getting to the close to population parameters is very high. Just one sample may not be sufficient enough for you to predict about population. You may go wrong, or there may be less confidence for you to talk about population parameters. So we are going to see this. Let's say we have got population of around 100,000 people, and we want to find out their age. One simple exercise would be to check age with everybody, which is not possible in real life, because it is difficult for you to go and check age for each. So what you normally do in this case is, let's say the population mean is 50. Okay, now what you do is you take sample. Okay, so you take one sample and try to find out what is the mean. Mean is, let's say, 45.5. Take the another sample and another sample and another sample, and typically when you do this many times, probably you will get a very close number to the population. But here one interesting thing that you see, that even if you take many samples, probably your mean may not be exactly equal to the population. So you will be very close to the population, and hence there is something called sampling error, or there is something called because you are taking a sample which is not the entire population, so there is possibility that you may not capture all the variations in that population, but it is good enough for you to predict about population using a sample which is very close to the population mean. So here in today's class we are going to learn how we do that in case of sampling distribution. Okay, so in this case you can see that sampling distribution, if I have got X number of samples, then more or less average or the mean age is not exactly same, but it is very close to the mean. So this we will see using a standard deviation. So typically what happens is this: when you have a population, you will find that there are extreme values, there are values which are very close to the mean, there are values which are little far from the mean, and hence you will find that the deviation, standard deviation or deviation from the mean is going to be little large. When you take a sample, typically you take very small part of the population. In that case, you will see that the distribution or deviation is not that great. So we are trying to find out that, and how close you will be with the population depends on your sample and the deviation in that sample. And how do you judge whether the deviation is more or less? Just you find standard deviation, and if for a sample standard deviation is very high, then you also assume that in population also the standard deviation is going to be high. Just imagine if you are taking a sample where everybody's age is 50, then in that case what is the deviation? Deviation is going to be 0. But if you see a sample where you have got people with a different age group, so in that case you will find that deviation is going to be large. Okay, now a population distribution and sampling distribution. Many people get confused what is the difference between these two. Population distribution is by taking all the observations in a population. Sometimes it is very difficult for us to get information about all the distribution observations of population and its probability. So what we normally do is we take a sample and try to predict about the population. Okay, so population distribution has mean, which is mu or x bar, and standard deviation is given by this formula. And then you have got if you have got a normally distributed population, in that case it is normally represented as x is normally distributed with mu as mu mean, and this is as standard deviation, sigma as standard deviation. Okay, and you get this scale which is known as standardized value, where if you have information about x and mu and sigma, then you get a z value, you get a standardized z value. Using this z value you can know the probability of that x. Okay, so in case of a sampling distribution, we do not have to take entire population. So typically in this case you will find that the mean is s, which may or may not be exactly equal to mu, but it will be certainly very close to mu. And then standard deviation is smaller in this case, and hence this standard deviation of population is divided by root n. So that you will find that if you have you find that standard deviation is less in case of sampling distribution. Okay, and this particular thing is also known as standard error, and this standard error has a lot of use in terms of calculating margin of error. We'll see this. And standardized value of a sampling distribution is exactly the same formula, that x minus mean of sample divided by this is standard deviation of a sample. Okay, so here in this graph you can see that the mean is exactly the same for both population and sample, but the spread is smaller in case of sample, because you are taking small sample which is less than the population, and hence the spread or distribution, or you can say the standard deviation is smaller. Now let's take a problem. Right, so the problem is very simple. The average height of all Indian follows a normal distribution. That means there is a normal distribution with respect to the height of individual, and where mu is mean, which is 150 given. Standard deviation is 5. So what is the probability that 10 random Indian height is less than 140 cm? So what is the meaning of this problem? Let me just explain. So you have got a normally distributed average height of people in India, and here mu is 150, standard deviation is 5. So here 150 is going to be the mean, and here the distribution is like this mean plus the standard deviation. So it's 5, you can get something like this. Okay, so you will find that our problem is about sample, because we are talking about 10 random Indian height you have taken. So now you can see that this is the sampling distribution of samples. So in this case you can take 10 random samples and height is 140. So 140 is somewhere close to this. So you are interested in this area. So what is the probability of this area? So this is what is the sampling distribution. So how do you solve this? Very simple. The mean is 150 given, n is 10, which is given, 10 random Indians you are taking. Standard deviation is nothing but the sigma of population, which is given as 5, and root n is the number of observation, here root 10. So this value you are getting as standard deviation of a sampling of a sample. Okay, and from this you can also get the z value, which is x minus mu. X is the variable that you have taken, so which is 10 minus mu, standard deviation, which is 4 by 5, and this whole value is 4 by 5, and you get minus 2.2. So this is the value you are getting. So now for z value minus 2.2, you have to go to the table of z table and find out what is the value of what is the probability of z value, which is minus 2.2, and you get the probability as 0.13. So what is the meaning of this? That basically means that if you take a random 10 individuals height which is less than 140, is nothing but it's only 1.13 probability. Probability is 1.13. So this is the probability of this area. So always when you take z value, it is always less than. Now let's say if it says that the problem says that 10 random height which is more than 140, more than 140 is always 1 minus whatever probability you're getting. So this is more than means it is this area, this whole area. So it is going to be 1 minus 1.3. Let's take one more problem. Here the problem is the score in chemistry in a school examination, which follows a normal distribution with mean is 70 and standard deviation is given as 5. What is the probability of all students scoring more than 80? That basically we want to know how many students, or what is the probability of students getting 80 and above score. So in this case, this is the information given, and standardized value, since it is all the students, so we are only talking about population, not the sample like the previous one. So here only thing that we need to find out about the population, what is the probability of scoring this. So it's very simple. So standardized value z that you found, first is x, which is 80 score, minus mu, which is 70, divided by standard deviation, which is 5. So answer is 2, which if you go to z distribution, you will get 0.97 as the probability. Okay, so here you have to understand that whenever you calculate z, it always gives you less than that value. So that basically means 97% probability, or 0.97 as probability, is for the student scoring 80 and less. But what is our problem at hand? Problem says that more than 80. So in that case, what you need to do, you need to find out 1 minus this probability as the probability of scoring more than 80. So that exactly means you are basically interested in this area. Okay, so this 97% is this one. So 97% probability is for the student scoring at least 80 marks or less than 80 marks. Okay, so here more than 80 is this particular area. So this particular area's probability that you get is 1 minus 0.97. So it is like 3% probability is there that students scoring more than 80. So this is an interesting way of seeing z distribution. This. So now we are interested in understanding confidence interval. So confidence interval is something like this. Please understand the story behind it. See, you are actually predicting or estimating population parameters like mean in this particular case using a sample. So there must be some error. Okay, so this confidence interval actually talks about margin of error that is allowed or that you can assign, and you will also find that if margin of error is less, that means you are more confident in estimating, or you can say that you are more confident about the results that you are getting. But if confidence interval or margin of error is big, probably your confidence will be little less. So this is the story, and how it goes, let's see this. Okay, so instead of predicting population mean, what you come up with a range. That basically means, if let's say if I say that mean is 50 plus minus 4, that means it can go up to 54 and it can go up to 50 minus 4, whatever that number, 46. So that range is your prediction. So that is what is confidence interval. Instead of giving you a number, you are giving a kind of range, and that is what is interval. So how do you find out, and what this interval depends on? As I already mentioned, it depends on the sample that you are taking. More bigger sample you take, you have more information, and hence your confidence level will go up and your confidence interval will become smaller. Let's say you take a population where you found that mean is there, but standard deviation is very low. Everybody is having the same weight. In that case, you will find that standard deviation is equal to 0. In this case, you will be more than sure, and your confidence interval is going to be smaller. Okay, so let's see how we can get this confidence interval. It basically depends on two things: your sample size. More sample means more information, and more information means your confidence interval is going to be smaller and your confidence will be higher. Okay, and the standard deviation, how different observations are from mean, is again going to be a very crucial factor in determining your confidence interval. Let's take one example. Here I have already mentioned this graph before, which basically says that when you take a sample always has the same mean, but the standard deviation is different from the population, and hence standard deviation from the sample you have to get it. Okay, so sample size is important. I already mentioned. So confidence interval is sample mean, which is x bar, plus minus, this is t statistics, students t test statistics, into standard error, and t into standard deviation of sample divided by root n is nothing but margin of error. Okay, so we have taken 95% so of t, so you can find out the value of t. So how do you find the value of t? It's very simple. So you can in fact have your own table very easily in Excel. So you use this formula in Excel, where you just mention your probability values and degree of freedom, and use this formula where t into inverse probability and degree of freedom. If you write in Excel, then it is going to give you the answer. Here I have written ABS is for absolute value, because if you put this, probably you will get negative value. So here you are going to get ABS, which is absolute value, so that this table you can derive. So in this case, you can get, for example, if sample size is 12, then in that case, if you want to have 99% sure confidence level of t, then in that case this 2.62 is the value. Anyway, so let's take one simple example where one engineer wants to know the cost of repair of collision. He has collected some information about 24 cars, and average cost of repair is 10,000. Standard deviation is given as 2000, and t value for n is equal to 24 is also given as 2.5. Then in that case, let's find out the confidence interval, and it's very straightforward. Just put the values here. X bar is given as 10,000, t value is given as 2.5, and standard deviation is 2000 divided by root n, and is your number of observation, which is 24. Just calculate the value. You get two values for the range. So your mean confidence interval is 11,020 to 8,979. I hope you liked whatever we discussed so far. In the next topic, I'm going to cover hypothesis testing. Till then, goodbye and take care. Bye bye.